Okay, and objective 2, we are going to write the equation now of ellipse in standard form. So picture again is anytime you have orbits of orbits of celestial bodies, those things happen in ellipses, as you can see in the picture. Now, I want you to go ahead and get out that flowchart, that amazing flowchart that you already printed from the last lesson here. So this information is on it, so you don't have to write it down again. But let's just go through it so everything makes sense here. So we've already looked at the points for the vertical major axis. Let's actually look at the equation together with this. So if I have a vertical major axis, vertical is in the direction of y's. First of all, that A, major axis is always 2a. Okay, so the major axis gets the a value, and the vertical is in the direction of y's. So look at the equation. The y is paired up. The y squared is paired up with the a because it's a vertical major axis. All right, and then the b is going to go with the x. And no matter what, these things are always equal to 1. You'll see why whenever I go to make myself have an equation in standard form. Okay, so we already looked at the points on this one, so let's go ahead and look at the points for the horizontal major axis. So on the horizontal major axis, again, major means A, it gets the 2a, and since this one's horizontal, this is in the direction of x's, right? Horizontal is in the direction of x's, and look down at the equation. This time the a squared is paired up with the x's, and the b squared is paired up with the y's. Okay, so if you notice things like that, it makes this pretty easy. Now, the center, of course, is always at hk, and since I have a horizontal major axis, whenever I go to add the focal length to that, or if I go to add the a value to it to get where my vertices are, it's going to affect the x coordinates. So here I have h plus c, comma k, that stays the same, and then I have h plus a for the one of the vertices, comma k. Okay, and then the minor axis is the one that is 2b, so I'm going to add b, and this is in the direction of y's this time, so add it to the k coordinate from the center point. And again, right down below we have the Anti-Pythagorean theorem that helps us, that's like not what it's really called, that's what I call it, to relate the A, the B, and the C together. Okay, so let me give you some pro tips here, I think. Some pro tips. So the first one is thinking about this Anti-Pythagorean theorem. So if you think of the picture of an ellipse, draw it so that if I pick the point on one of the co-vertices and I link it up to the one of the foci, it traces out a right triangle. And if I were to take just use the Pythagorean theorem on that, b squared plus c squared, and take the square root of that, that's got to be equal to a. And the reason why is because if I were to put the other one in here, this length, d1 plus d2, those things are going to total up to 2a. So if this is exactly half of it, that one's got to be a. Square both sides of that, and then finally get the b squared over there, and then you have it. The c squared equals a squared minus b squared. Okay, here's another way to think of this. On the equation for the ellipse, it is always separated. The x squared and the y squared is always separated with a plus sign. And in the Anti-Pythagorean theorem that relates the a, the b, and the c together, the a and the b are separated with a minus sign. These things are opposite. This is going to be really, really helpful whenever we also talk about the hyperbolas, because that relationship is going to be exactly the same thing, but those signs are going to switch. The negative is going to be on the equation, and the positive is going to be on the Pythagorean theorem thing. Okay, here's some more pro tips. So remember that the length of the major axis is 2a. It's pretty easy to remember. A goes with A. And the minor axis has the 2b. Which one of those is bigger? Major is always bigger than minor, so 2a is always bigger than 2b, which means that a is always bigger than b. So something to keep in mind. The bigger number goes underneath whatever axis is the major one. So the a squared is going to go underneath, if I look down at the equations there, if it's a vertical major axis, the a squared is going to go under y because that's in the direction of y. and the b squared is going to go underneath the x, which is the minor axis. If it's a horizontal major axis, this is in the direction of x's, so this time the a squared goes with the x squared term, and the b squared goes with the y. Okay, here's a question. For an ellipse, what happens if the a value and the b value are the same? Well, that means that the major axis and the minor axis are the same length. What shape do you get? Obviously, you get yourself a circle. So this is not exactly a circle just yet, but if I move my C closer, or my foci closer to that point C, this will start to look like a circle. And where are the foci going to be? The foci are going to be exactly on top of the center point. That's interesting. Okay, so now let's put this stuff together and actually come up with the equation. This will polish off this video, and then we'll look at it with some equations in the next one. So find the standard form of the equation of an ellipse having these 2 points as foci and a major axis of length 10. If I have major axis of length 10, so 10 must be equal to 2a, which means that a is equal to 5. So there's my first piece of information. Okay, my foci are on the major axis. Let's look at this major axis. The y coordinates are staying the same and my x coordinates are changing. This must be a horizontal major axis. Okay, if it's helpful, just sketch yourself a little picture of all of this little information. Okay, I need a center point for this. The center point is, of course, going to be the midpoint between these two foci. So the center is going to be at -2 plus 4 over 2. And the y coordinates, they're staying the same, so that's 2. So -2 plus 4 is 2, divided by 2 is 1. I got a center point at 1, 2. I have my a value, I need my b value, and then I have all my information. To find my b value, I need to find the c first, so then I can put it in the Anti-Pythagorean theorem. So the c value is going to come from these two coordinates. So 2c is equal to, I'm going from 4 to a -2, so 4 minus a -2 is equal to 6, which means the c is equal to 3. Now let's put those things together in the Anti-Pythagorean theorem in order to find the length of b. So c squared is equal to a squared minus b squared. I'm going to put in 3 for the c, so 9 is equal to, and then I'm going to put in, what was it, 5 for the a, so that's 25 minus b squared. Get the b squared over there, get the 9 over here, so b squared is going to be equal to 16, and my b is equal to 4. Hey, and this makes sense. The a is bigger than the b, and that should always be the case. So now let's put everything together and write our equation. So x minus 1 from the center point squared. This is a horizontal major axis, so the x is going to get the a. So 5 squared is 25. That goes on the bottom of that. Plus y minus 2 squared over whatever my b squared is, and that's 16. All this is equal to 1. And there's my equation. And that was fun. Alright, yeah, that's it for this one anyway.